Okay, let's just forget all the complex, crazy jargon you've probably heard about blockchain, because at its heart, it's actually a really simple and powerful idea. Today, we're going to break it all down using something we all know, a simple notebook. So let's open it up and see what's inside.
I mean, seriously, think about that for a second. What if a notebook, something totally ordinary, had just a few special rules that completely changed everything about how we agree on things and record information? Well, that's the core idea we're going to dig into today.
So, here's the fundamental concept. A blockchain is basically just a shared digital notebook. Imagine a whole group of people, and every single one of them has an identical copy of the same book. When a new page is added, boom, it gets added to everyone's copy at the exact same time. But here's the most important rule, the real magic trick. Once a page is written, it's sealed. You can't erase it, you can't tear it out, it becomes a permanent, shared record of the truth for everyone.
Now, just like in the real world, the rules for who gets to see and who gets to write in this notebook can be very, very different. And this brings us to a really key distinction.
This distinction leads us right to our first major topic, public versus private blockchains. And to really get the difference, let's imagine two totally different places, a wide-open town square and a secure private company office.
These two settings are the perfect way to think about the main types of blockchain. So, on one hand, you've got the public blockchain. Think of this as that notebook sitting right in the middle of a public square. Literally anyone can walk up, read all the pages, and even try to add a new one. It's all about openness, right? Total transparency. But then, on the other hand, you have the private blockchain. This is more like a company's internal confidential ledger. You need permission, you need an invitation just to look at it, let alone write anything in it. This is all about control and privacy.
Okay, so this is where it gets really interesting, seeing how these differences actually play out. When it comes to access, public is what we call permissionless. Anyone can jump in. Private is permissioned, it's invitation only. This means participants on a public network can be totally anonymous, while on a private one, they're known and they're verified. And that directly affects speed. Public blockchains, well, they're slower because they have to coordinate this massive global network of strangers. Private chains, they're way, way faster. And this leads to completely different uses. You see things like cryptocurrencies on public chains and then things like supply chain management on private ones.
And you know, it's not just one or the other. There's also this sort of hybrid model called a consortium blockchain. The best way to think of this is like a group of companies, say a bunch of different banks, all agreeing to share and manage one single notebook together. It's not totally public, but it's not controlled by just one company either.
This is where the story gets really, really exciting. You see, the early blockchains were great at just recording stuff, kind of like a simple calculator. But then, some innovators started asking this incredibly powerful question. What if this shared notebook could do more? What if it could actually do things based on what was written inside it?
That single question led to a massive leap forward. The notebook learned a new trick. It got smarter. And this is our introduction to the world of smart contracts. Now, the concept might sound super complicated, but I promise you, the best analogy is something we've all used. So for a second, just forget about code and picture a simple, ordinary vending machine.
I mean, think about the logic, right? It's a simple if-then agreement. If you insert the right amount of money and you press the button for your choice, then the machine is programmed to automatically give you your drink. There's no cashier, there's no negotiation. The agreement is just enforced by the machine's programming. It just works.
And that simple logic, that is exactly what a smart contract is. It's a digital vending machine that lives on the blockchain. It's an agreement where all the rules are written directly into code, and it runs itself, it executes itself automatically whenever those rules are met.
And this digital vending machine, well, it has three superpowers. First, it's self-executing. It just runs all by itself. Second, it's tamper-proof. Because it lives on the blockchain, nobody can go in and change the rules after it's been set up. And third, it's transparent. Anyone who has access can look right at the code and see exactly what the rules of the agreement are. No hidden clauses.
All right, so theory is great, but let's see how this really shifts things in the real world. Let's take this idea of an automated agreement and apply it to a situation we can all understand.
So, let's imagine you and a friend, you want to place a friendly little wager on a big cricket match. It's a simple, everyday kind of agreement. So how would we normally do this, and how does a smart contract completely change the game?
And this example really shows the fundamental change here. The old way, it's all about trust, right? You make the bet, and you just have to trust your friend to pay you if they lose. But with a smart contract, you both lock your money into the contract ahead of time. The contract is programmed to automatically check a reliable sports website for the final score. As soon as that result is posted, it automatically sends all the money to the winner. Trust is completely removed from the equation. The entire process relies only on the certainty of code.
So, let's bring it all home with the key takeaways. First, blockchains are not one size fits all. They can be public and open for everyone, or private and controlled. Second, a smart contract is really just a digital vending machine that automatically enforces an agreement. And maybe most importantly, this technology lets us build systems that replace the need for human trust with the absolute certainty of code.
And that leaves us with a really fascinating final thought to chew on. This shift from trust to code, it's a profound one. When the very foundation of how we make agreements changes, what does that unlock? If you can create any kind of binding agreement that runs itself perfectly without needing to trust another person, well, what will we build next?